Hi, I'm Mrs. Dawson. I'm going to be teaching your math lesson today.
JK, it's DJ M. Rob. I'm not going to let Das teach your math lesson any more than she's going to let me teach you your English lesson. So in any event, let's turn to page 9 in the percent increase decrease packet, and I'm going to make this one pretty quick. It's not that easy. You have to do a lot of this thinking on your own. Just check this out. We're going to look at different ways of looking at the same thing. You'd be surprised on how different something looks, but they're talking about the same thing. So just working, how do we read this? That's 0.90 times C. You don't see the times sign in between a number and a letter. Let's remember that the number in front of a letter is called the coefficient. So this is like saying 0.90 of a cookie. That's like 90% of a cookie. 10% or 0.10 of a cookie. So if I was going to read this, I would say a cookie minus 0.10 of a cookie. So I say a cookie, how many cookies is this? That's one cookie. What happens when you have one cookie, take away 0.10 of a cookie? What I want you to do right now is on a sheet of paper or a whiteboard, I want you to show me with a picture of a cookie. Show me a cookie taking away a tenth of the cookie. Draw that for me and show it to me. Pause the video so that when you're ready you can move on to the next section. Now I want you to, after you've shown me that cookie minus 10% or cookie minus 0.10, because 10% and 0.10 are the same thing, okay, circle the expression that represents 10% of means what? Of means times the original cost. If more than one answer is correct, explain why you chose those answers. Explain means you need to use words. I'm just going to run through this, then you're going to pause it and do it all. Put a box around the expression that represents the final cost of an item after a 10% decrease. Think, what's happening if you take 10% off of something? You know, it helps when you draw a bar, and this is 100%. Everything starts at 100%. Think, what happens when you take 10% off? If more than one is correct, explain with words why the expression you chose are equivalent. Now, the next thing I want you to do is create a word problem involving the percent decrease so that the answer can be represented by this expression. Make a word problem for that. Then you're going to make a word problem for percent decrease that you would use this one for. They both end up with the same answers, but it's a different kind of question. I'll give you an example in a second. And then at the last one, Tyler wants to know if it matters if he uses 25% decrease as 0.25x or as 1 minus 0.25, get that answer and then multiply it by x. In the space below, explain that. So I can show you, pause the video and do at least section A and B. I know you guys are going to hesitate on the word problem, so I'll give you my example, and then you're going to have to write a new one by at least changing a few words. Okay, pause. Give me your answers for A and B. All right. I circled 2 is the answer for A. I boxed in 1 and 3. You know that's Greek. You know the I stuff? It's 1, 2, 3 in Greek. Counting Greek. So here's 1 minus 0.10 is the same as 0.9. If I have a cookie and I take away 0.10 of the cookie, I then have 90% or 9/10 of the cookie left. So I'm supposed to write a word problem for expression 2. I find the amount of decrease if it's 10% off the cost. So I would do 10% off, 0.10c, and then I would have to do subtraction if I want the final price. Or just what is 10% off of a cookie? Question D, write a word problem for A. What am I left with after I take 10% off my cookie, which is 0.90? Or what do you pay after a 10% discount? So for example, in the last question, 0.25x tells you the amount decreased. You want to do 25% decrease. 25% of the number tells you the amount you decrease. If you want to know what you get afterwards, you have to then subtract. If you do 1 whole times your number minus the 25% off decrease, you will get your final answer. 1 minus 25 is 0.75x. Does it in one step. This helps you with algebra in the future. Okay, when you're done with that, we're going to turn to the next page. I'll go through one example, and then you'll work on the rest and check your answers with me. Okay, so this is all reading and labeling. That's all you need to know. We're doing proportions, and they always have to have matching units. So, let's go with question 1. Devin reduced his weight from 250 to 200 pounds. Find the percent of change. So I always start a word problem with what do I want? I want percent, so that's X, and it's of change, so you have to label this. What is the percent change out of the original? What did he weigh originally? He started at 250 pounds, so 250 goes here. If you got this labeled, you should know what goes here. How much is... Oops, I messed something up. Did you find my mistake? Percent's always out of 100. Okay, and the original weight started with 250. That goes over here. This is my percent side. This is my weight side. How much is the change in weight? If he went from 250 to 200, the change was 50. Okay, and that's how you start these. Finish this one, and then check all your answers for 1 through 5 with me. Okay, have a good day. Oh, by the way, if you finish all that, you can treat yourself to the video Mathematicious, and then you can listen to that while you work. It's the best.